The Embraer 175 is a narrow-body, twin-engine jet airplane with low wing, conventional structure, conventional tail, tricycle landing gear, pressurized cabin, and it was designed for short to mid-range flights. Manufactured by Brazilian aircraft manufacturer Embraer. E-jets are designed from a double-bubble fuselage concept, a shape derived from vertically overlapping two ovals to produce a four-abreast cross-section. The upper oval forms the main cabin, which is a 2-meter high cabin. Electronic and cargo compartments are located in the lower oval. E-jets incorporate a human-focused design approach, emphasizing physical and cognitive requirements and abilities. The cockpit was designed with ergonomic placement of instruments and controls in a dark and quiet environment. The passenger configuration consists of 4 seats abreast. The E175 typically seats around 78 passengers in a typical single-class configuration, 76 in a dual-class configuration, and up to 88 in a high-density configuration. The E175 incorporates fly-by-wire technology that helps to reduce pilot workload, improves aircraft performance, simplifies systems architecture, and minimizes weight and maintenance. Between its primary users are Republic Airways, SkyWest, Envoy, and Mesa. The tricycle landing gear is fully retractable, with dual wheels for each strut, and oleo-pneumatic type shock absorbers. The main landing gear retracts sideways. The nose landing gear retracts forward and has a normal steering angle of about 76 degrees. During a turn with full deflection of the nose wheel, the largest clearance is required by the tail, which is not visible. Pressurized areas include passenger cabin, cargo compartments, electronic bays, and recirculation bay. The fuselage is pressurized between the forward pressure bulkhead, located forward of the cockpit, and the aft pressure bulkhead, which is located behind the aft electronics bay. Normal pressurization control is automatic, and the conditioned air is provided by 2 air conditioning packs located in the unpressurized area forward of the wing root. A glass panel cockpit is installed with a highly integrated onboard avionics system. The design and installation of systems are developed with the objective of obtaining easy physical and functional integration among them. 4 doors and appropriate ground support equipment clearances expedite turnaround time. The cockpit can accommodate 2 crew members on the pilot seats and 1 observer on the jump seat. 2 flight attendants can be seated in the cabin. There are 2 galleys and 2 toilets. The cabin also features a wardrobe built next to the front passenger entrance. There are 2 cargo compartments below the passenger cabin, 1 in front and 1 behind the wing fairing. Fuel is stored in 2 integral wing tanks. Control cables drive the ailerons. The other flight control surfaces are controlled electronically using fly-by-wire technology. Integration between 3 modular avionics units results in faster data processing, enhanced safety and system redundancy, and an overall improvement in efficiency. The information refresh rate is determined by the frequency of equipment utilization, thus optimizing data processing. It is powered by 2 high bypass ratio wing-mounted turbofan engines. The engines have a wide chord fan for aerodynamic efficiency. The General Electric CF34 engines produce 14,200 pounds maximum thrust each and are able to reverse thrust to enhance aircraft braking capability. Engine controls and fuel scheduling are provided by a full authority digital electronic control. It has an auxiliary power unit mounted in the tail cone to provide electrical and pneumatic power. The Embraer E175 is designed to operate from short runways. Is able to approach airports with steep approaches. Has a certified ceiling of 41,000 feet. Has a maximum cruising speed of Mach 0.82. And depending on the long or normal range version, it can reach destinations up to 2,200 nautical miles. To maximize performance, a variety of modern composites, like fiberglass and carbon, have been used. These materials are lighter in weight and more durable. The aircraft is equipped with an adjustable stabilizer and multifunctional spoilers. Aerodynamic characteristics are enhanced by leading-edge slats and ground spoilers to give the references necessary for the identification of the service areas and components. The aircraft is divided into major zones, major subzones, and zones. The major zones are identified by a number which increases by the hundreds, from 100 to 800, which refers as follows: 100 fuselage below the floor line, 200 fuselage above the floor line, 300 empennage and tail cone, 400 power plant and pylon, 500 left hand wing, 600 right hand wing, 700 landing gear and landing gear wheel well doors, 800 passenger, service, and cargo doors. The major subzones increases by tens, from 10 to 90. The zones increases by units. It identifies a component and its location. Even number shows the right side. Odd number shows the left side. The identification of fuselage access doors and panels helps to locate units, components, and work areas on the aircraft. It includes the 3-digit zone number identification, one letter which identifies the door or panel in a logical sequence, starting with the letter A in each zone, one letter related to the aircraft zone, T for top, B for bottom, L for left, R for right, Z for internal, and a third optional letter, F for floor, W for sidewall, C for ceiling, and the kind of fasteners used are given by tables. There are 3 jack points, 2 on the wing's lower side and 1 on the rear fuselage lower side. Aircraft partial jacking is done on the jack point of each landing gear. Above 31,000 kilograms, only partial jacking is permitted. Maximum fuel asymmetry between wings is 800 pounds. It is not recommended to lift the aircraft on jacks when persons are inside. Make sure that the aircraft is lifted in the maximum 2.5 meters from the jacking point to the ground. Always make sure that the landing gear safety pins are installed and the aircraft is statically grounded.